When we think about a water crisis, our minds usually jump to things like droughts or just plain running out of it. But what if I told you the real issue isn't about how much water we have, but how we manage it? Today, we're going to look at a totally different way of thinking about water, not as a resource problem, but as a systems challenge. And to really get our heads around this, let's start with this quote from Anuj Sharma at Argyam. This one idea, it's literally the key to unlocking the entire water puzzle. It's not about what you've got, it's about what you do with what you've got. And you can see this idea in action if you look at two places in Rajasthan, India. You've got Bharatpur, which gets plenty of rain, but believe it or not, they struggle with water shortages. Then you have Bikaner, deep in the desert, and they have a reliable water supply. So what gives? It's all about management. It proves that just getting more rain doesn't mean your water's secure. So this brings us straight to our first big idea, what I'm calling the Great Water Paradox. We're about to break down the numbers, and trust me, they're probably not what you're expecting. Okay, we all learned this in school, right? Our home is the blue planet. A massive 71% of the Earth's surface is covered in water. I mean, from way up here, it looks like we've got an endless supply. But the second you start to zoom in, that whole picture changes dramatically. Because out of all that water, only 2.5% of it is actually fresh water. The rest, it's all saline. It's all in our oceans. All of a sudden, that huge blue marble feels a lot smaller. But, and this is the kicker, even that 2.5% number is kind of misleading. Right? Because when you subtract all the fresh water that's frozen solid in glaciers and ice caps, the amount that's actually accessible to us, flowing in rivers and lakes, the water for all 8 billion of us, it's less than 1%. That tiny, tiny sliver has to support all of humanity. It's pretty mind-blowing. And here's what that looks like in a chart. It's almost all saline water. That little slice of the donut, that 2.5%, that's all the fresh water we have on the entire planet. It's just a really stark visual reminder of how finite this resource actually is. Okay, so if we're going to talk seriously about this challenge, we've got to make sure we're all speaking the same language. You hear a lot of terms thrown around, so let's take a second to decode the crisis and define what they actually mean. So first up is water shortage. This one's personal. Think of it at the micro level. It's about you, in your home, at your tap, not having enough water for your daily needs. Drinking, cooking, cleaning. It's an individual problem. Now, let's zoom out a bit to water scarcity. This is a much bigger deal. It's a regional issue. This is when the total water sources in an entire area, like a whole river basin, just can't keep up with the demands of the population that lives there. And finally, we've got water stress. This is more of a forward-looking term. It's a big red flag. It means a country is using a ton of water compared to its supply, and those sources are running down. It points to scarcity in the future. And this is where India officially stands today. It's a water-stressed country. So where's all this water going? Well, the answer might surprise you. We focus a lot on turning off the tap at home, but our domestic use, that's only 5%. Industry uses about 4%. The overwhelming majority, the real elephant in the room, is agriculture at a whopping 91%. That means the single biggest place we can make a difference is in how we grow our food. But hey, it's not just about how much water we have, it's about the quality. Unsafe water is a huge problem. You've got pathogenic contaminants, think bacteria and viruses, that cause fast-acting diseases like cholera. They're nasty, but we're pretty good at treating them. The much trickier problem is often geogenic contaminants. These are natural chemicals like arsenic and fluoride that leach out of rocks. They cause slow, long-term health issues and are way harder and more expensive to get out of the water. Okay, we've laid out the problem, and it's a big one. But now let's shift gears and talk about solutions, because this is where things get really, really interesting. We're going to dive into a case study that shows a totally new way forward. So let's go back to Rajasthan, a region dealing with high levels of that tricky geogenic stuff, fluoride. And the old solutions, they just weren't cutting it. Trying to build piped infrastructure to remote villages was way too expensive. Bottled water was unaffordable for most and created a mountain of plastic waste. And those little home purifiers, they were inefficient, and when they broke, good luck finding someone to fix them. And then came Piramal Sarvajal, which means water for all. And their approach was, frankly, genius. They didn't just sell a product, they delivered a service. They set up these central village-level purification plants and then empowered local entrepreneurs to run them. They used remote tech to monitor water quality 24/7. And to solve that final hurdle, getting the water to the people, they invented these solar-powered water ATMs. It gives people access to safe, affordable water anytime. It's a total game changer. So, the Sarvajal model is an incredible example of systems thinking for a physical resource, for water, which gets you thinking, what happens if you apply that exact same logic, building an open, accessible network, to the digital world? Well, that brings us to India's digital blueprint for solving problems on a massive scale. The key concept we need to understand here is something called digital public infrastructure, or DPI. Now, the absolute best way to think about it is like digital roads or railways. They are these open, shared platforms that anybody, the government, a private company, a startup, can build on top of to create new services. And India's world-famous DPI is known as the India Stack. It has 4 main layers. There's a layer for digital identity, a layer for paperless documents, a layer for instant, free payments, and a layer for you to control your own data. Put together, this system has absolutely transformed what's possible in daily life across the entire country. And seeing this incredible success story just begs a really powerful question. If we can build these amazing open digital roads for things like identity and money, what if we applied that exact same blueprint to water? So for our final section, let's just explore that vision for a minute. What would a water stack for tomorrow even look like? What could it do? Well, the vision is basically to create a digital nervous system for water. Imagine a public map of every single pipe and pump in the country. Imagine sensors everywhere, streaming real-time data on water quality that anyone could check on their phone. Imagine an app where you could see a leak, snap a picture, and instantly report it to the right person. You'd finally close that feedback loop between the people using the water and the people providing it. So, we'll end on this thought. We have built these incredible digital highways that let money flow instantly and freely across an entire nation. So why can't we do the same for the one resource that's even more essential to life? If we have digital rails for money, why not for water?